Hello and welcome to helpyourmath.com. In this video, we're going to look at an introduction to rational exponents. And before we get into rational exponents, let's just review what the word rational means. The word rational basically just means a fraction or decimal. So a rational number is a number that could be written as p over q, where p and q are both integers. So basically it's just talking about our standard fractions. Okay, so let's look at the definition of a rational exponent. A rational exponent is of the form x to the a over b. So just to rewrite that, because this program isn't the best about this, this is where a over b is the exponent. So x is the base, and the exponent is a over b. Okay, so that's what it looks like. And then we have some restrictions. X is a real number, a and b are integers, and specifically b has to be a positive integer. So a little bit going on with b, but it must be a positive integer. So how do we deal with these things? Well, let's start with our unit fraction. So if the exponent is a unit fraction, meaning we have 1 over something, we can rewrite that as the b root of the base, the b root of the base. So for example, if we have 9 to the 1/2, we could rewrite that as the square root of 9, which is equal to 3. If we had, let's say, 64 to the 1/3, that would be equivalent to the third root of 64, which is equal to 4. So basically, if we have an exponent and there's a denominator, this becomes the index of a radical. So this becomes an index of a radical if we were to put the base inside a radical. If we look at just any old rational exponent, so x to the a over b, what we want to do is we want to think about it as x to the 1 over b, then to the a. Now, where do we get this from? Let's just talk about this before we get into the second half of this bullet point. Why is this allowed? Well, for two reasons. We need to have understanding of two things. One is power to a power. So you might recall from just any old exponent that if we have x to the m to the n, we can simplify this to x to the m times n, because power to a power, we can multiply the exponents. So we're kind of doing the reverse of that. Now you might be saying, wait, a over b, that's not multiplication, but we can write it as multiplication. So a over b, we can pull the a and separate it as a separate factor from the b, and it would become a times 1 over b. So then we would have x to the a times 1 over b, which now we have a product, right? Just like we do up here. So now we're just going to go completely backwards and say, okay, well, I actually want to do this first, and then I'm going to raise it to the power of a. Why do we do this? Because we hope that x is a perfect b power. And then if it is, we can clean that up and get something probably smaller, and then we raise it to the power of a. So let's look at an example. If we have 8 to the 2/3, we could rewrite it as 8 to the 1/3 squared. And then what we could do from here, we could say, wait, this is the same as the cubed root of 8, and 8 is a perfect cube, and its root is 2. So what's inside the parentheses becomes 2, and then it becomes 2 squared, which is 4. So as you can see, it was to our advantage to rewrite it with just that unit fraction inside the parentheses, and then the actual power outside parentheses. Looking at some examples, so we're going to look at examples of writing radicals as exponents, and then we'll look at examples of writing exponents as radicals. We're going to take each radical expression and write it as an exponential expression. So radical expression means we're going to have something like the b root of x to the a, and we want to rewrite it as x to the a over b. That's what it's ultimately going to look like. So our first example, we have the square root of 7. The index here, we want to keep in mind, is 2. So this we could rewrite as 7 to the 1/2. 7 to the 1 over 2. In our second example, we have an index of 4 and a radicand of 6. We can rewrite this as 6 to the 1/4. Here we have the cubed root of x to the 5th. Okay, so this time it's going to look just like this up here. We're going to say, okay, this is the same as x to the 1/3 to the 5th, which is x to the 5/3. So we would want to leave it like this with just one exponent. Question 4, okay, we have 3 different radicands here. we have an index of 2, so each exponent will have a denominator of 2. This would become x to the 3 over 2, y to the 7 over 2, and z to the 1 over 2. Each one gets their own unique exponent, and they all get denominators of 2 because of the index of 2. And lastly, we have 5 times the 5th root of x to the 4th. The 5 is unaffected by anything going on with this. This would become 5 times x to the 4 over 5. Okay, now we're going to do the reverse as promised. We're going to write exponents as radicals. So we're going to rewrite each exponential expression as its equivalent radical expression. 9 to the 6 over 11 to the 6/11ths. This means we have an index of 11, and then it would be 9 to the 6th. And if it was smaller, I might compute it, but it's not, so I'm not going to. I'm just going to leave my answer like that. And remember, what we're doing here is we're taking x to the m over n and rewriting it as the nth root of x to the m. Oops, sorry, I think previously I used a and b, but now I switched to m and n. It happens. Okay, here we have a base of x cubed plus y, so those are stuck together. They're going to be stuck under a radical. It's going to be the 5th root of x cubed plus y. Oh, here we have a curveball. We have 5 times c to the negative 2/3, d to the 8/5. For the negative exponent, remember what a negative exponent means. It means that that base actually doesn't want to be where it is. And so we could put this whole thing over 1. It would be in a numerator, and it wants the reciprocal of that. When we take the reciprocal, be very careful. We only take the reciprocal of the base. So I'm going to rewrite this first as 5d to the 8/5 over c to the 2/3. The exponent stays as it is, as the fraction. The 2/3, we do not take the reciprocal of that. We only take the reciprocal of the base. Now we have to put this in exponential form. So this would be 5 times the 5th root of d to the 8 over the cubed root of c squared. Okay, our next example, we have some work to do because we have power to a power. So the first thing I want to do is rewrite this as r. So this is like 3 over 1. So that's 2 times 3, 6 over 7. Now I know the index is 7, and it'll be r to the 6th. One more example, we can barely squeeze it in. Uh-oh, we have another negative. So that negative again means take the reciprocal. That means everything's going under 1. That's 5 plus 3e to the 6th to the 1/4. And that would indicate that 1/4, that we want the 4th root of our base here, which is 5 plus 3e to the 6th. Just to summarize what we did here, so x to the 1 over b can be rewritten as the b root of x. X to the a over b can be rewritten as the b root of x to the a. X to the negative 1 over b could be rewritten as 1 over the b root of x. And of course, if we had an a up there, we would just say x to the a. Thank you for stopping by.